Extrinsic Semiconductor Part 2. Objective: to study N-type extrinsic semiconductor. N-type semiconductor. When a pure semiconductor like silicon is doped with pentavalent impurity such as arsenic, 4 of its valence electrons form covalent bonds with the adjoining silicon atoms. The 5th electron is very loosely bound with the arsenic atom. This electron, on acquiring a little energy, leaves the impurity atom and becomes a free electron. The pentavalent impurity atoms thus donate electrons for conduction to the semiconductor crystal. Hence, they are called donors, and the energy level of the donated electrons is called the donor level. In other words, the energy level of these electrons is a little below the lowest energy level of the conduction band. At room temperature, the donor level electrons can easily move into the conduction band. The conduction band electrons outnumber the holes in the valence band, generated by thermal agitation, by many orders of magnitude. Hence, the free electrons are referred to as the majority charge carriers and the holes as the minority charge carriers. These electrons in the conduction band are responsible for the conduction of current in the N-type semiconductor. Thus, the electrical conductivity of the semiconductor is greatly enhanced due to the remarkable increase in the number of free electrons. As the net charge in both P-type and N-type is 0, doping does not disturb the neutrality of the semiconductor. Conductivity of extrinsic semiconductors depends not only on the temperature but also on the extent of doping. That is, 1 part of a donor impurity per 10 to the power 9 parts of germanium increases its conductivity by a factor of nearly 10 to the power 3. Hence, we are in a position to understand how doping can produce a dramatic change in the electrical conductivity of a semiconductor. Summary: in an N-type material, Ne is extremely larger than NH. We refer to the large number of free electrons as the majority charge carriers and the relatively small number of holes as the minority charge carriers. The current in the extrinsic semiconductor is mainly due to the majority charge carriers in it. The electrical conductivity of the extrinsic semiconductors depends on the temperature and the extent of doping. It is to be noted that both P-type and N-type semiconductors are electrically neutral.